I welcome you all for the data structure class. Today we'll start with the model number 4. Okay, so that is the concept of trees. Okay, tree is nothing but what? A finite set of one or more number of nodes that shows how the parent-child relationship exists. So there is a special case called root node. Okay, the remaining nodes are called as what? The subset of the tree. So as you seen in the figure, here A is represented root and remaining all are the B, C, D are the subtrees of the tree. Okay, and the terminologies. So we'll see what are the terminologies of the tree. So this is the tree representation: 100, 50, 60, 70, 80, 40, 35 and 30. Okay, so these are the tree representation. See here. So here 100 in this figure, what you are having 100 is called as what? The topmost element of the tree, that is called as root node, parent. A node having left or right subtree, we are calling it as what? Parent node. Okay, so here if you consider the node 60, it is called as parent node of 80 and 40. Okay, next is called as what? Child node. Okay, so the node obtained from the parent node is called as a child node. Okay, see here, for 50 and 60 are the child nodes of 100 is the parent, 50 and 60 are the child nodes. Siblings, two or more nodes having the same parent is called as what? Siblings. See here, 50 and 60 are having the same parents, these are called as what? Siblings. Ancestors, the nodes obtained in the path from the specified nodes while moving upwards towards the root node are called as the ancestors. Here 60 if you consider is the ancestors of both 35, 30, 80 and 40. So all these come under 60 only. So 60 is the ancestors of all these nodes. Okay, similarly descendants. Okay, the node below the root nodes all are nothing but what? Descendants, left descendants. The left part of the tree we are calling it as what? Left descendant. Right part of the tree we are calling it as what? Right descendants. Left subtree. All the nodes that are the left subtrends of a node from the root node we are calling it left subtree. Same right hand side we are calling it as what? Right subtree. Degree, the number of subtrees in a node is called as what? Degree. For example, 100 node, you are having 50 and 60, so it's 100 node is having a degree of 2. Leaf nodes, the nodes which is not having any sub nodes we are calling it leaf nodes. See here, 70, 35, 30 and 40, these are called as what? Leaf nodes, internal nodes. Except the leaf nodes, all other nodes are called as what? Internal node, external nodes. The nodes which is not link, having a R link or L link only. See the example, 70 it is not having L link and R link, and similarly 30 not having L link and R link. These are all called external nodes. Okay, level, the level is nothing but what? The distance of a node from root node to the leaf node we are calling it as what? Level. So here the node 35 and 30 are at the level 3 because 100 is at the level 0, 1. Level 1 is 50, level 2 is 70, and 35 and 30 is at the level 3. Okay, height. So the maximum height of the tree is what? So we are having 3 levels, so total height is what? 4. Okay, so this is how, these are the representations we are having for the trees. These are terminals you are using for a tree. Next we'll see with how we can represent a tree. Okay, how we can represent the tree, representation of a tree. So tree can be represented in 3 ways: list representation, left child right sibling representation, binary tree, left child representation. First we'll see with the list representation. Here first what you are having, the root node comes from immediately followed by the subtrees. Okay, next recursively you are having a subtree. See here, see the tree here, A is the root node, next you are having subtrees B, C, D, again B is corresponding to E, F, like this way these are subtrees. If you represent using the links, how it can be: A is the root node, A is first child is what? A is first child, next second child, third child. Okay, next first child is what? B, next B is next connection is what? To E. Okay, like this way the connection can be made. Next, left right sibling representation, how you can make left right sibling representation. And see here, left right sibling representation, how you can make so for example, see the example here, A, B, C, D you are having. So you connect all the nodes on the left hand side of the tree as it is, but what are the next nodes? C, D you are having, you are connect to B to CD. Okay, similarly you go on connecting to the left hand side, then we are calling it as what? Left child right sibling representative. Right sibling will be connected to the left sibling only, so that representation is called as what? Left sibling representation. Okay, so this is how we can make up of the tree. Okay. So I hope you clear with the definitions. So tree, what do you mean by tree? What is root node, child node, parent node, level, internal nodes? Next you can represent, how you can make in the form of list representation, how you can make in the form of sibling representation. In the next class we'll see with the concept of the binary tree and examples and properties of the binary trees. So you can go through the videos. So for next videos we'll start with the next concept. Okay, thank you.